Good evening, geometry students. So today we're going to be working in section 2-4, and it's called deductive reasoning. And today I'd like for you to be able to use two laws that we're going to talk about today during these notes, and they're called the law of detachment and the law of syllogism. And when you use those laws, you're going to come to conclusions. So first we have some definitions that we're going to cover, then we'll jump right into some examples for you. We've already covered inductive reasoning. Remember, inductive reasoning, we use patterns to figure out what future elements in that sequence will be. For deductive reasoning, however, we are going to use logical reasoning. Or at least that's another word or way that something else that deductive reasoning is called. It's sometimes called logical reasoning. And what you do, it is reasoning based off of given statements and facts. So now, instead of using a pattern, we're going to use information that we were told. So then we have two different types of laws that we can use with this in deductive reasoning. The first one is called the law of detachment. And what we have here is, if the beginning of a statement is true, or if the beginning of a true statement is true, then the conclusion is also true. So let me write that out. If the beginning of a true statement is true. So that's important. We're assuming that this stuff does in fact happen. If the beginning of a true statement is true, then the conclusion is true. So let's talk about an example. Here we have a given, and given just means this is what we know. So here's what we know in this example. If it is raining, then it is cloudy. We know this. We also know it is raining. So we have our conditional, if it is raining, then it is cloudy, and then we were told an additional piece of information. It is, in fact, raining. So our conclusion can then be, it must be cloudy. So the conclusion is, it is cloudy. So here, you know what's supposed to come one after the other. You're given the beginning, so you assume the end based off of this true statement that we're given here. Next, we have something called the law of syllogism. The law of syllogism allows you to state a conclusion from two true conditional statements when the conclusion of the first is the hypothesis of the second. So I'm going to kind of abbreviate this a little bit, and I am going to say the conclusion of the first is the hypothesis of the second. Now, I know this is kind of a short and abridged definition, but I just kind of want to boil it down to its bare bones, sort of, or to its stock. So let's look at an example, and then I think you'll see what I mean by the conclusion of the first being the hypothesis of the second. So let's say that we have the phrase, if it is July, then it is summer. This is true. If it is July, then it is summer. We also know if it is summer, then Haley swims. So now we have two if-then statements, and they flow one to the next. If it is July, then it is summer. If it is summer, then Haley swims. Notice the conclusion or the ending of the first one matches the beginning of the second one. So what we're allowed to do with this law of syllogism is kind of like cutting out the middleman. So now we're able to say, if it is July, then Haley swims. So here, instead of using the if it is summer kind of middle step, we can go straight from if it is July, then Haley swims, because the it is summer is consistent in both of those conditionals. Okay, now that we have these definitions, let's look at a couple examples. In example 1, it says, determine if the conclusion is valid by using the law of detachment. So remember, the law of detachment is when we have a true statement and the beginning of it, that statement is true, so then we can conclude the end of the statement or the conclusion. So in this example, it says, given, if a vehicle is a car, then it has 4 wheels. Okay. My vehicle is a car. Because this statement is true, we can then conclude the ending, and the conclusion is my vehicle has 4 wheels. So yes, we are able to use the law of detachment here. In example B, it says, if you study, you should pass the test. Frank studied for the test. This is all in the given. Then it says conclusion, Frank studied for the test. Well, notice here that it just repeated the given again. So this conclusion is wrong because nothing has been deduced from it. So I am going to say no for that one. We would need to say Frank should pass the test for our conclusion. In example 2, we are doing the same thing as up here, but we're going to determine if we can reach a conclusion based off of law of syllogism now. So it says, if 2 angles are vertical, then they are congruent. If 2 angles are congruent, then they have the same measure. So notice, this is key, the ending of the first statement, they are congruent, is the beginning of that second statement. So we know that matches right off the bat. And then it says, if 2 angles are vertical angles, then they have the same measure. So logically, that does follow because we're now cutting out this middleman. So if 2 angles are vertical angles, then they have the same measure. So this is yes, we can make a conclusion from this. For B, it says, if a number is divisible by 2, then it is even. If a number is even, then it is an integer. So once again, we do have the it is even at the ending of the first and beginning of the second. And then it says, if a number is an integer, then it is divisible by 2. Here, this is done incorrectly. We have to conclude this going forwards, not backwards. So this would need to say, this down here, it would need to say, if a number is divisible by 2, then it is an integer. But this is actually backwards, it's the converse. So we're not allowed to do that, so this one is no. Okay. Now looking at the back of your paper, we just have a bunch of examples that we're going to go through so we can kind of put the law of detachment and the law of syllogism into practice a little bit better for us. So we're going to determine if we can even make a conclusion. We might not be able to. And then if we can, which law did we use and what conclusion should it be? So letter A, it says given. If you drink milk, your body gets calcium. If your body gets calcium, you will have strong teeth and bones. So first of all, you should notice your body gets calcium is the ending of the first statement and beginning of the second. So this is going to let us apply the law of syllogism. So I'm going to write that over here. Then I'll write out our new conclusion for what we can write. And that's going to be, if you drink milk, then you will have strong teeth and bones. Okay. Next, for example B, it says, if it is snowing, then it is cold outside. It is cold outside. Because the it is cold outside is not the hypothesis of the other statement, we cannot conclude anything. So we are going to say no conclusion. It is important that you're following those strict rules of it being in the correct order, because as we know and have seen in class already, changing the order of a statement or a series of statements can change what they mean and then change the truth value of them. So because it is cold outside is not the hypothesis of the statement, we cannot make a conclusion. In example C, it says given, if you study, you should pass the test. Tim passed the test. So this is very similar to example B. We weren't given the hypothesis, instead we were given the conclusion. So we can make no conclusion yet again. All right, now we're in example D. So it says vertical angles are congruent. Angle ABC and angle DBE are vertical angles. Okay, so here we know that vertical angles are congruent. So we're going to say that this is the law of detachment. So if angles are vertical angles, then they are congruent. This one wasn't written the best way. I apologize for that. So these angle ABC and angle DBE satisfy this first part of angles being vertical. So we are going to say this is going to satisfy the law of detachment. So now we are going to say that angle ABC and angle DBE are congruent. And I'll remind you of the symbol for congruent one more time. It's the equal sign with a little squiggle over top of it. In example E, it says, if you break an item in a store, you must pay for it. Jill broke a vase in Potter's gift shop. So, Jill broke a vase in a store. It was an item in a store. So we can then conclude that she must continue on in this phrase of paying for her item. So this is once again the law of detachment. So because Jill broke a vase in Potter's gift shop, we're now going to say Jill must pay for the vase. Moving right along, here we have example F. It says, if a number is a whole number, then it is an integer. If a number is an integer, then it is a rational number. So here we have then it is an integer as the ending of our first statement, and a number is an integer as the beginning of our second statement. So we are now going to be able to use the law of syllogism. Wrong color. And we're going to cut out the middleman, and it's going to say if a number is a whole number, then it is a rational number. Okay, we have 3 more examples to go. On G, it says, given, if a dog eats dog food delights, the dog is happy. Fido is a happy dog. The issue with this is, once again, Fido is a happy dog is the conclusion of the statement and not the hypothesis. So we know right off the bat, no conclusion can be made. For H, it says, angles that are complementary have measures with a sum of 90. Angle A and angle B are complementary. So here, we're going to say that angle A and angle B, once again, this statement isn't written the best. So I'm going to put in an if angles are complementary, I'm going to say then they have measures with a sum of 90. That'll just read better for you. So here we have angle A and angle B are complementary. So this is going to give us the law of detachment. So I'm now going to say angle A and angle B have measures with a sum of 90 degrees. I apologize about that. That should have had an if-then in there. Finally, for our last example, it says, all fish can swim. Fonzo can swim. We cannot make a conclusion based off of this. All fish can swim is just a statement, and then Fonzo, we have no idea if he's a fish or, a human or anything like that. So no conclusion can be made. This is far too vague of an example, and we need a little more specificity. So here you have it. These are the end of the examples for our notes today. If you have questions, make sure to bring them to me to class tomorrow.